Hello students, welcome to Eshwari Taniksha channel. Students, in this video we are going to learn tricks to find the basic strength of aromatic amines. That is, when aromatic amines are given, how to find their basic strength. So let us write trick number 1. So students, on aliphatic amines I have already done a video. So if you have not watched, you can watch that video. So on aromatic amines, trick number 1 is, when you take ammonia, ammonia is NH3. So ammonia is found to be more basic than aniline, NH2. So why it is? What is the reason? So the reason is simple. That is, here this lone pair of electrons which are present on nitrogen is found to be localized. And here this lone pair of electrons are found to be delocalized. Delocalized meaning is it will be involved in resonance. See here, this is connected to benzene ring. So this electrons will move here and then this electrons will shift. So it is involved in resonance. Therefore, this electrons can be easily donated by nitrogen because it is localized. So basic strength meaning is it should easily donate the electron. So here it can easily donate this lone pair of electron because it is localized. Here it is difficult because it is delocalized. So this is trick number 1. We'll go for trick number 2. So trick number 2 is, so let us take aniline NH2 with lone pair of electron and then take anilium ion. That is, aniline, if it takes a proton, it becomes NH3 plus. NH3 plus. So here nitrogen has lone pair of electron and here nitrogen has positive sign. So which is more stable in this? So here you can see this is more stable. This is less stable. So why it is less stable? So let us see the reason why aniline is more stable and anilium ion is less stable. So let us take aniline. NH2, it has lone pair of electron. So now this lone pair of electron is involved in resonance. So this will move here and this electrons will shift here. So as a result, you will be getting double bond NH2 single bond and here a positive sign and here you will be getting a negative sign. So in the next step, this electrons will shift here and this electrons will shift here. So you will get, so a bond here, double bond NH2 and then positive sign on nitrogen and negative sign here. Next step, negative sign will shift here and this bond will shift to this carbon. So you will be getting double bond NH2 and then negative sign here, positive sign here. In the next step, negative sign will shift here and then double bond will shift back. So you will be getting NH2. So here how many resonating structures you are getting? This is 1, this is 2, this is 3, this is 4 and this is 5. So totally there are 5 resonance structure for aniline. We'll write for anilium ion. NH3 plus sign. So here the resonance structure you can write like this. So here double bond, instead of double bond here, let us write double bond here, then here and then here. NH3 plus. See here the position of double bond is different here. So here double single, single double. The positions of double bond are changing. So this is one and this is second resonating structure. So totally two resonance structures are there in anilium ion. So students, more the number of resonance structure, the molecule will be more stable. So here number of resonance structures are more. Therefore, aniline is found to be more stable when that of anilium ion. So this is trick number 2. We'll go for trick number 3, which is very important. So trick number 3 is to the aniline, if electron releasing group is attached at meta and para position, it will be more basic when compared to aniline, and this will be more basic when compared to aniline if electron withdrawing groups are present at ortho, meta or para position. So this is trick number 3. So here let us, when we take example, we will understand why the order is like this. Next is trick number 4. So trick number 4 is, this is aniline, and then this is aniline, and to the aniline if we attach a group, so this group can be electron releasing group or it can be electron withdrawing group. If it is present at ortho position, it is always less basic than aniline. So aniline will be always more basic when compared to this. That is when the group is attached at the ortho position. So that group can be electron releasing group or it can be electron withdrawing group. So this is due to, what is the reason for this? The reason for this is SIP. So what is SIP? SIP is steric inhibition of protonation. So we'll understand this. What is the steric inhibition of protonation? So first take aniline. So this is aniline. When you protonate this, it will form N, hydrogen, 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 and there will be positive sign here. After taking this proton, it gets a positive sign. So now this will be stabilized. So this will be stabilized by solvation. That is, you can see hydrogen bonding between this hydrogen and oxygen. So here also it will be solvated, oxygen. So here this proton is, so here you can see a positive sign is present. So the cation is stabilized by solvation. So more the stabilization, more will be the basic nature of the molecule. So it is stabilized more here. Therefore aniline will be more basic in nature. So let us take this one now. That is ortho substituted group. Aniline, and here there is a ortho group. So let it be electron donating group or electron withdrawing group. So first we are doing protonation. So you will get N, H, H and then H, a positive sign, and then there is a bulky group at the ortho position. So now, so this hydrogen will be solvated by water molecule. This hydrogen will be solvated by water molecule. Whereas here it is difficult to solvate this hydrogen by water molecule because a bulky group is present at the ortho position. So therefore here the stabilization is less by solvation. Therefore it becomes a weak base. So whenever a group is attached at the ortho position, it is less basic when compared to aniline. So this is about steric hindrance of inhibition of protonation. So next we will see trick number 5. So students, whatever we have learned the tricks, we will apply for this example. So I have taken 4 structures, 1, 2, 3, 4. So let us find the basic nature, which is more basic and which is less basic in nature. So here you can see CH3 group, that is methyl group is attached everywhere. Methyl, 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 and here this is aniline. So you know that always whenever a group is present at the ortho position, that will be less basic when compared to aniline. So we will write this first. This is less basic. And CH3 is present. So CH3 will show plus I effect. That is electron releasing group. So electron releasing group will be more basic when compared to aniline. So this two will be more basic than aniline. So aniline will come next. Now in this two we have to compare which is more basic in nature. So here this will show plus I effect, and here at the para position it will show plus I effect and also hyperconjugation. So because of this two effect, here it releases electron more. It increases the electron density on nitrogen more. Therefore this is more basic when compared to this structure. So therefore third one is more basic and then second. So this is the order. So next example we will take. So NO2, what kind of group is NO2? NO2 is electron withdrawing group. So ortho position, if a group is present at the ortho position, it is always less basic than aniline. So we will write this first. This will be less basic than aniline. Now we will compare these three structures. This is electron releasing group, electron withdrawing group. So electron withdrawing group, if it is present, it will be less basic than aniline. So this two will be less basic than aniline. So this will come in the first position. So first position. Now let us see among this which is more basic in nature. So here NO2 will show minus I effect, and here at the para position it will be showing minus M effect and also minus I effect. So here because of minus M and minus I effect, so it will be reducing the electron density on nitrogen more. So strength is more here. So because the strength is more, it is less basic when compared to this structure. So here second and then third. Sorry, here aniline will come in this position. So 4, 2, 3, 1 is the order. So next, chloro group is attached, and this is aniline. So chloro group at the ortho position. So whatever is present at the ortho position, it will be less basic compared to aniline. So its position will be here. Then we will compare this three. So in this three you can see chloro group is electron withdrawing group. So electron withdrawing group will be less basic than aniline. So this will be in the first position. Aniline will be in the first position. So now we will compare this two. So chloro group at the meta position, it will be showing minus I effect. Whereas here at the para position, it will show minus I effect, And here you can see chloro group is present at the meta position and here it is present at the para position. So minus I effect is depends on distance. So closer the distance, it shows more effect. Minus I effect will be more here because the distance is less. So because of which it reduces the electron density on nitrogen, making it less basic compared to this one. So this will be more basic. Third will be more basic when compared to second one. So this is the order of basic nature. So students, I hope you understood. So I'll meet you in the next video, students.